Hello everyone. In today's lecture we are going to discuss the machine learning. This is what the syllabus of the fourth unit. The objective is that of today's lecture to learn and understand the basic concepts and types of the machine learning. Course outcome is that apply concept of natural language processing to problems leading to understanding of cognitive computing. So first of all, what is the machine learning? So it is a branch of artificial intelligence that concerned with the design and development of algorithms that allow computers to evolve behaviors based on empirical data. This is what the technical definition of the machine learning. As intelligence requires knowledge and it is necessary for the computers to acquire the knowledge. The learning system model, it is like the input samples are there, then training that will be performed on that system or that input samples, and then whatever that learning method is there, then testing will be performed on it. So training and testing, this is very important. So whatever the data that we have, so few data, yes, we can use for the training phase and few data that can be used for the testing phase. So you can see we have the universal set of the data. So that is what the data acquisition, then training that can be performed on that, and once the training is performed on the data, then we can say that yes, one, the class of the data is separated from the other class of the data. Yes, you can see the left side box, and then yes, we can apply. Once the training phase is applied, then yes, testing that can be performed on the, that is what the practical uses. Suppose we have the unlabeled data and we have to predict the class of that data, then yes, we can use the testing phase. So training and testing, that is very important. So training is the process of making the system able to learn. So no free lunch rule. So training set and testing set that come from the same distribution. So need to make some assumptions or the bias. So you can see here. So set of the data, then training that can be performed, then testing that can be performed. Yes, how to measure the performance of the machine learning algorithms? There are some several parameters that are affecting the performance. The types of the training that provided, then the form and the extent of any initial background knowledge, the type of feedback provided, the learning algorithms. So which learning algorithms you are going to use, it is also that impacts the, we can say that one of the factor on the performance. Two important factors, modeling and optimization. So first of all, what is the algorithm? It is a success of machine learning system also depends on the algorithms. So the success of machine learning system depends on the algorithms. The algorithm controls the search to find and build the knowledge structure. And the learning algorithm should extract useful information from the training examples. Here a few classification, we can say that, or few types of the machine learning algorithms: supervised, unsupervised, semi-supervised, and reinforcement learning. Supervised learning, in which yes, we can see there are the set of the input data, that is xn, that is what the features of the data, and y is a label data set. Okay, so it may be label more than one label, multi-label we can say that, or two label data set. Okay, so prediction and classification, for that purpose the supervised learning algorithms are used. For classification, discrete labels are considered, and regression, so real values are considered. Then in unsupervised learning, actually there is no label data set, means label is not available for the given input features. So probably clustering, then probability distribution estimation, finding association in features, dimension reduction, that comes under the unsupervised learning. So in which actually no label data set is provided, no label is provided with the input features. So clustering that get formed with the similar kind of the data. So semi-supervised learning, in which we have some labeled data set and we have unlabeled data set. So from the labeled data set, yes, we can give the label to the unlabeled data set. That is what the semi-supervised learning. It is, we can say that the combination of the supervised and the unsupervised learning. And last one is that reinforcement learning, when we don't have any kind of the data, so at that time reinforcement learning will be useful. So it is used for decision making by robot or with chess machine. See, these are the three diagrams, basically supervised learning, unsupervised learning and semi-supervised learning. So in the first diagram, yes, you can see supervised learning, three classes are there and that is get separated. In unsupervised learning, clusters are formed having the similar kind of the properties or having the similar kind of the relationship among that data. And semi-supervised learning, yes, you can see there is some mix of the supervised and the unsupervised learning. Machine learning structure. So you can see in supervised learning, initially we have the some data set in data set, that is what training takes, document images and sounds. From that data, yes, we can extract the features, that is what the data set, and along with that extract the features, along with that extracted features, so labels are also provided for that extracted features, right? So it is given to the machine learning algorithms. Then machine learning algorithm is get perform on that training data set, we can say that training phase, and that forms the predictive model, right? Then whatever that unlabeled data that we have, so we can consider, then we can extract the features from that data, whatever that data available, right? And that based on that feature vector, right? So predictive model get applied over it and extract the label, that is expected label. In unsupervised learning, yes, the previous diagram, when we see in which actually the label data is available, but in this there is, in this diagram there is an absence of label data, right? Process is similar. So machine learning algorithms that forms the model, right, and get the input data, okay, and yes, we have to actually find out the likelihood or cluster ID or better representation, means we have to determine whether that particular data set is belongs to which class. Learning techniques. In under the supervised learning categories, there are many techniques. Linear classifier is used, that is numerical function. Parametric, that is probabilistic function under which naive Bayes. Then Gaussian, discriminant analysis, hidden Markov models, probabilistic graphical model. And in non-parametric approach, actually k nearest neighbor is there. It is instance based function. KNN is used, kernel regression is used, kernel density estimation, local regression. In non-metric, it is symbolic function, classification and regression tree, decision tree is used. And aggregation, that is bagging the bootstrap plus aggregation, it is a combination of bootstrap plus aggregation. Then AdaBoost and random forest is used. So these are the supervised learning categories. Unsupervised learning categories, clustering, under which k-mean clustering and spectral clustering. Under density estimation, Gaussian mixture model is there, graphical model is there. And under dimensional reduction, their PCA is there, that is principal component analysis and factor analysis. What are the applications of the machine learning? The common applications like that: face detection, object detection and recognition, image segmentation, multimedia event detection, economical and commercial uses. These are the general application, but it is very vast area and machine learning can be applied in any domain. So conclusion, of this today's lecture is that we have a simple overview of some techniques and algorithms in machine learning. Furthermore, there are more and more techniques apply machine learning as a solution, and in the future machine learning will play an important role in our daily life. So reference is there, WL Chow and JJ Ding, so integrated machine learning algorithm for human. So the slide contents which are taken from this reference. Thank you.